we know that circumference is the distance around the circle, and pi is the ratio of the circumference to the diameter. Now, you should know this theorem, circumference of a circle. Circumference of a circle is pi times the diameter. And you can also use pi times 2 times the radius. And how come we can do that? Because the radius is just the diameter divided by 2, or the diameter is 2 times the radius. That's where the 2r comes from. D is just 2r. So we can use pi d or 2 pi r. This is a length, which means your units will just be the unit. Now, some other information here. Pi is irrational, which means it is not terminating. It's a non-terminating decimal. If we want to approximate pi, 3.14 is a good approximation. 22 divided by 7 will give you the full decimal, and the pi key on your calculator gives you a nice long decimal as well. It depends on what amount of accuracy you like. I like the pi key on my calculator. If I'm working by hand, I tend to do 3.14. You could also do 3.14159. But know that the fewer decimal places you use, the further off you'll be on rounding. So when you're checking your answers, if you're off by a decimal point or two, rounding error. We've dealt with this before using pi. All right. Coplanar circles. What does coplanar mean? In the same plane. So coplanar circles, so you draw circles on a piece of paper that have the same center. So they have different radii, but the same center are what we call concentric circles. And concentric circles are just a bullseye. You just make a different radius, keeping your compass at the same point in the center, or your piece of string in the same point in the center, and you just change your radius and you get concentric circles. So what are we going to do with this? Well, these are some fun problems. In this problem, we have a 2-foot wide circular track. So we know that this is 2 feet here. Is set up for a camera dolly on a movie scene. On those scenes where, you go around the actors, they're done like this. The 2 rails of the track form concentric circles. The radius of the inner circle, so this guy right here, radius of the inner circle is 8 feet. And how much farther does a wheel on the outer rail travel than a wheel on the inner rail? Well, how are we going to know the radius of the outer circle? Well, the radius of the outer circle is this. What is that? It's the inner circle plus the 2 feet of the track, so it's 10 feet. So now, think about this. Like cars on a racetrack, you notice how they often stop at the pit stop and change the tires frequently? Well, they're changing the tires based on that outer wheel, those tracks that just go around in a circle, because look at this concentric circle here. If you're running around the inside, you're going a lot less of a distance than if you're running around the outside. This is why for track and field competitions, runners on the track, you start running at different places. They're staggered so that the people on the outside are not running farther than the ones on the inside. So anyway, our outside wheel is traveling farther. So we find the circumference of the inner circle. We know radius, so we're going to use 2 pi r, and we get that to be 16 pi feet. And then we find the circumference of the outer circle. Again, we have radius, so we'll use 2 pi r, and we get 20 pi feet. So to find the difference in the two distances is 20 pi minus 16 pi. So it either travels 4 pi feet, which is 12.6-ish feet further. So that's really far. In one rotation around the actor, it travels 4 pi more feet, travels 12.5 feet more. So that's a lot. And guess what? Now it's your turn. Pause the video. Do the next couple of problems. All right, the first problem was easy. Our car has a turning radius of 16.1 feet. The two tires are 4.7 feet apart. You drive around in a circle. How much farther do the outside tires go? So my inner radius is 16.1 feet. My outer radius is that plus 4.7, so 20.8 feet. Circumference is 2 pi r because I have radius. And I get 32.2 pi feet and 41.6 pi feet. I take outer circumference minus inner circumference, and I end up with 9.4 pi, or 29.5 feet. So just driving around in a circle once is almost 30 feet farther on those tires. So imagine if you're in those race cars going around those big tracks, those outer tires are going to wear out a lot faster than the inner ones. Okay, the second problem says, suppose the radius of circle A, that's my big circle here, is equal to the diameter of circle B. So the radius of A is the diameter of B. You can see that's what I've got drawn there. The radius of A is the diameter of B. What is the ratio of the circumference of A to B? Well, I just called the diameter of B x, and that means that the diameter of A is 2x, because just a radius. Radii are congruent. And then I just did my formula. I got 2 pi x and 1 pi x. The pi x is going to cancel. It's just a 2-to-1 ratio, which makes sense because imagine if this were a polygon, we would be comparing side lengths. And the side lengths on the big polygon would be 2 times longer than the ones on the small polygon. Circles don't have any sides, so we are comparing their radii. Radius is just a length. We're comparing lengths, so if one is twice as long, your ratio is going to be a 2-to-1. All right, well, why do we care about circumference? Because we want to talk about arc length. The measure of an arc in degrees, I don't know what that says. We're going to skip that part at the beginning. I don't know what they're saying there. Arc length is a fraction of a circle's circumference. Notice the word length in the word, right? In our term here. So we're going to calculate this as a fraction. So this is arc length. We have arc measure, which is in degrees. Arc length is a distance. Arc measure is in degrees. Arc length is a distance. The length of an arc is the product of this ratio, the measure of the arc over 360, and the circumference. Because think about it here. This is a fraction of the entire circumference. Well, how do we find that fraction? Well, this angle is a fraction of 360. So look at our equations here. We have the measure of our arc, that's our angle measure, over 360 times our circumference. And this one is if you know the radius, this one is if you know the diameter, and these are just both the measure of your arc times the circumference. Well, measure of the arc divided by 360. But this is circumference. This has to do the fraction of the circle. Let me erase that. That's just our circumference there. Let's look at this in action. We want to know the length of each arc shown in red. Well, I will put them in red for you. We are asked for arc XY. We are asked for arc XPY. That means we go around this way. All right, let's look at the first one here. What does our angle measure? That's 90 degrees. And so what is our arc measure? Well, that's 90 degrees. How much of this circumference are we using? 90 over 360, that's 1/4 of our circle. That should not cause you any problems. Okay, we have a diameter here of 16, so I just plug it in. This is the measure, the length of our arc is the measure of our arc over 360 times our circumference, and we have diameter, so we use pi d. So this is, if you look at this as 1/4 times 16 over 1, and then times pi, because 90 over 360 is 1/4, that's where this 4 comes from. Let's look at our other one. What do we know here? We know our radius is 15, and our arc measure is 240. What fraction of our circle is that going to be? 240 over 360. These are both divisible by 12. So these are both divisible by 120. So a 2:3 ratio. And this one we have radius, so we use 2 pi r. This is 2:3 times 30 over 1. I did 2 times 15 and got 30 over 1 times pi. So these are going to cancel, 1, 10. That's where we get our 20 pi from. All right, that means that it's time to pause the video and you work on the last problem. This wasn't too bad. We were given the length of a semicircle. That means the measure of our arc is 180 degrees with a radius of 1.3 meters. You write your formula. The length of the arc is the measure of the arc over 360 times circumference. We have a radius, so 2 pi r. 180 divided by 360 times 2 pi times 1.3. 180 over 360 is 1/2. And then I did times 2 over 1 times 1.3 over 1 and put pi out at the end. We were asked to leave our answer in terms of pi. My 2's cancel and I'm left with 1.3 pi meters. So as long as you label everything you know, write your formula, substitute in, life will be good. All right, let's look at this last concept here. It says, it is possible for two arcs in different circles to have the same measure, but different lengths. Now, what does that mean to us? So, let's imagine that we have a small circle and a big circle, and we want our arcs to have same measure but different lengths. Same angle but different length. So what that says is the arc measure, right, degrees, is the same, but look, this arc length, this one's all short here, and this one's long because it's a bigger circle. So we have the same angle here, but different lengths. Now, what's our next one? It is possible for two arcs, two different circles, to have the same length, but different measures. Well, how does that work? You've probably got this figured out by now. Small circle, big circle. We want them to have the same length. How are we going to get this short little length here on our big circle, this short little length? Well, we have to have a much smaller arc. So these have a, not the right color, different angle, but the same length. Now, congruent arcs are arcs that have the same measure and are in the same circle or congruent circles. So we have circle O is congruent to circle P, and what does that tell us? They have congruent radii, because that's how we judge circles, which tells us that these are congruent arcs. Not only are the measures the same, but their angles are congruent as well. So we could mark those congruent like that. It's not exactly the way, but that works. So our arcs are congruent as well. Our circles are congruent, therefore our radii are congruent, and then everything is congruent. So just something to think about circles. They're really just polygons without sides doing the best they can using their radii. All right, well, a lot of new concepts in this one. It is so important that you draw your diagrams, label everything that you can, and then write your formula and start figuring out where things go. Being able to see these is going to make them easier to do. They are challenging, but I believe that you will do very well on these. So have fun on your homework.